My name is Tuhin. Today we'll be building an intelligent agent with memory using LangGraph. So this is the fifth episode in the LangGraph series. So this video is going to be interesting. So please watch till the end. So we'll be building an AI agent with memory and we'll store the conversation history in a text file for the future analysis, and we'll be integrating OpenAI GPT-4o model for the AI capability. Now, what is agent memory? Agent memory usually comes up in the context of LLM and agents like LangChain and AutoGPT. And what is agent memory? Agent memory is how the agent keeps track of the past interactions and knowledge, so it does not start fresh every time. It is like context sensitivity. So whatever is asked previously, those things agent will be remembering, and if you ask the question again, then agent will take a context from the previous conversation and will be able to answer the question. Take an example like during the conversation, I tell the agent my name, like my name is Tuhin, and in the after next few conversation, if I ask the agent my name again, that do you remember my name or what is my name, then agent will be able to remember that name and will answer that properly. So without the memory it is not possible. Now, for creating agent state for managing context, we will use this particular data structure for the agent state. That is a list of union of human messages and AI messages. A list of union of human message or AI messages is, so it list will contain either human message or AI message. So both human message and AI messages are class in LangChain code library. So we'll be importing both of the classes from this LangChain code libraries. So for the prerequisites, we'll be using Python 3.12.4. So you need to have 3.12 at least if you want to follow along with me. And required Python packages are LangGraph, Python.n, LangChain, and LangChain OpenAI. So LangGraph is used for building graph-based agentic AI, and Python.n will load the keys from .env file. So we'll be storing the OpenAI API key in the .env file. Then LangChain will use for accessing core LangChain library functionalities. As you know, the LangGraph is based on LangChain, so few LangChain functionalities will be anywhere required. LangChain OpenAI is used for accessing OpenAI capabilities from the LangChain. And finally, we'll be creating similar graph that is available here. We'll have a start node, we'll have an agent node. Agent node will have a capability for the interactions with the OpenAI, and finally it will have end. Agent node will also be responsible for storing the data, storing the previous conversations in the memory. Now let's see it in demo. Now, as I mentioned, 4 libraries will be required. For we need to run the command poetry add LangGraph space python.in LangChain so it mentions that all of the libraries are already available, so I added them already, so it's saying nothing to add. So we'll quickly go to our project. So here is the project. As you see, all the libraries are already available: LangGraph, Python, .env, and LangChain and LangChain OpenAI. Now we will go to agent with memory directory and we'll create few files. So first file is schema, and inside the schema, so we have added the class agent state of type dictionary, and here we have the property called messages, and messages is a type of list of union of human messages and AI messages. As I described earlier, that the list will contain either human message and AI message, and both of the classes come from LangChain code library. Next file will add nodes, and inside nodes, so let's see line by line. First we have loaded the .env. So this will be used for bringing the OpenAI API key, and here we have created an integrated the ChatGPT, and we have used model GPT 4.0, and we'll use this LLM to invoke the user message what we'll be taking from the users, and finally we'll get the response, and whatever the response we'll get, we'll add it as an AI message. Okay, and finally we'll print the AI generated response, and then current state also will be showing in order to check the what is being stored in the memory, and finally it will be returning the state. Next we'll create another Python file called graph. So first we created the graph with the state graph, and we have taken the agent state as a parameter, and graph we have added the node, agent node, and that is the agent node we have already created in the nodes.py, and we have given it a name, the agent node, and then we have connected that agent node with the start node, and then agent node with the end node. End node and start node are predefined nodes in the LangGraph. And finally, we'll be creating another file called main, from where we will be running that project. So let me explain from the beginning. So these, up to these particular portions will be used for generating the visual graph. Okay, and then for the conversation history, we are getting a list for storing the conversation history, and we are keeping a counter. Then we are taking the user input and storing the user input, and we are checking until user input is not exit, it will continue, and we'll add the human message in the conversation history. So previously we have seen in the node we were adding the AI response in the conversation history. So here we are adding the human message in the conversation history. So finally we are getting the result, and result, if you check it here in the, we are passing the conversation history on the agent.invoke. So what it means, it will send the entire previous conversation as well to the agent. Now finally we will be storing the entire conversation in the conversation history.txt file. So for that we are iterating over the conversation history, which is nothing but a list, and we are for each message we are checking whether it is a human message or whether it is an AI message, and based on that we are writing it for you, or that is the human message that what we asked, and what is the AI generated response. Finally we are storing ending the conversation, and we will be storing the conversation history in the conversation history.txt, and we'll need to create another file here, that is conversation history.txt, and one more of directory you need to create where the visual graph will be generated. So now we are ready for the final demo. Let's see. Now it is asking us to enter, so I'll say hi. Now AI generated response, hello, how can I assist you today? In the current state, you can see that both of the messages got added. One is the human message up to this, and another is AI message. So human message contains hi, and AI message contains the generated response. Now I will tell my name is Tuhin. You see the AI response, it says hello Tuhin, I just a computer program, and etc etc. So now another two messages got added. First message is hi, second message is AI response hello, and second again is the human message that I have entered, and third is the AI response, that is the AI message got entered. If you check this, then you can see that. Now we'll see an interesting observation. That is, I already told that my name is Tuhin. Now I'll ask the agent that what is my name. Now let's see the response. AI is responding as, you mentioned that your name is Tuhin. How can I assist you further? So it took my name from the previous conversation or the memory, and it responded with my name. Now we'll simply exit, and we have And now you can see the conversation history got populated, whatever the conversation we have done till now. So hi, hello, and then human message, then AI message, what is my name, the AI message, and the end of conversation. Finally I ended because I exited. Now you see the in the output graph also has been generated: start, agent node, and end. It's a simple graph which where the agent node is managing the most of the things like agent memory and the invocations to the OpenAI. But now we'll see one more important thing. Now I'll run once again. Now I have restarted the program and I'll ask the agent what is my name. Now let's see what is the answer. Now it says, I'm sorry, but I don't have access to the personal data about individuals. Now, interesting fact is that the memory that was temporary, so it got uh, deleted once I restarted the program. So if you want to store the memory in a persistent basis, or want to store somewhere where from where we can continuously access, we can store it in a persistent database like any SQL database or any NoSQL database as well, in order to get the previous context or previous memory as well. So this is the end of the demo. Now in the next episode, we will learn how to finally build a LangGraph React agent, which is will going to be very interesting. And next, we'll use LangSmith for tracing, which is very important for building a production grade agent. So stay tuned. If you liked my video, please like, comment, share, and subscribe. Thank you for viewing.